an old concept from last semester, but it is on your chapter 6 test. So we need to go over it again. Yes, same base exponential equations. Okay, what you do is you take the base that's bigger. So what I mean by bigger is this one's 6 and this one's 216. So I'm looking at the big numbers basically, and I make a factor tree. So 216. And I'm a really big nerd. We know this. I know what multiplies to be 260. Go ahead and, but you might have to mess around on your calculator before you, what? 6 and 36, which is 6 and 6. Okay, so what that means is 216 is 6 to the third. So on this side, I have 6 to the negative x minus 2, and then 216. I'm going to change that to be 6 to the third. And now they have the same base, and I can cross them out. Negative x minus 2 equals 3, plus 2, plus 2. Negative x equals 5. Divide by negative 1, x equals negative 5. Okay, now, if this is, it's not super easy, but it's quite a bit easier than this one. So 64, you guys probably know that's 8 times 8, and 4, and 4, and 4, and 4. Now, if you want to bring that all the way down to 2s, you can, but you don't have to. But what you should notice is that there's nothing that's 16 here. There are no numbers that are 16. 64 is not 16 to the something. So I have to do 16 also. But I know that's 4 times 4. So what I did was I turned this into a 4 base, and I turned this into a 4 base. 64 is 4. Wait a minute. None of you are going to say anything. Were you? Well, 8 is not 4 times 4. 8 is 4 times 2, which means there's 1 4, 2 4s, 3 4s. Yeah, not 4 4s, 3 4s. Mm, really special. Okay, and 16 is 2 4s. What is 4 to the 4th? I think it's 256. Okay, so 64 is 4 to the 3rd, and then you put the x plus 2 exponent in parentheses right next to it. We're going to distribute. And then the 16 becomes 4 squared. And then you put the negative 2x in parentheses. Oh, this one's quite a bit harder. It's like a puzzle. You have to figure out which base. Cancel out the 4, so I have 3x plus 2 equals 2 times negative 2x. This side I'm going to distribute, so I have 3x plus 6. And this side you just multiply, that's negative 4x. This one's not going to have a nice answer, huh? Spicy. Do you want Emily? Okay, does she know where you are? Okay, okay, thank you. Um, okay. Now, do not put your packet away. We are doing a resource page in here. Has to do with yodelers and xylophones. This one. So find this big graph and then just Sound of Music. Yeah, this is a Sound of Music word problem. Um, if you guys could just set this aside for the moment. And then set up your notebook with this. That's cool. Okay, now the book picked kind of a fun scenario. Xylophone and yodeler is fun to say, also fun to imagine. Also, the Sound of Music is fun. They also did it because they wanted to pick words that were easy to make letters for. What's a really good letter to assign the word xylophone that has to do with algebra? Yeah, X. What's a really good letter to assign with yodelers that has to do with algebra? Yeah. So they were trying to make it really easy for you guys to pick what letters you wanted to go with xylophones and yodelers. So that was why there's a bunch of reasons. But anyway, I don't know. I'd like to think that they were trying to make it fun. Okay. So on 67, literally all we do is put, okay, we're going to call xylophones X and yodelers Y. That's my favorite problem of all time. I know. Okay, now 68 is not so easy. So 68 is, we're going to have to do some of that word problem translation that we've been working on. Okay. Start by focusing on one aspect of the problem. Oh, I got to read the problem too. That would be really helpful. Okay. The hills are alive. The Alpine Music Club is going on its annual music trip. The members of the club are yodelers and they like to play the xylophone. I just want you to take a minute, think about what that would sound like. Yodeling, xylophone. This year, they're taking their xylophones on a gondola to give a performance at the top of Mount Monk. The gondola conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club, including the xylophones, to ride the gondola. Two yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. I've already lost you. Okay, so for 67, all we had to do was identify the letters. Now for 68, we're going to break it into little pieces. Start by focusing on one aspect of the problem, the cost to ride the gondola. The conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club with instruments to ride the gondola. Okay, so we're going to translate that into algebra. We're going to say $2 for each yodeler and $1 for each xylophone. Imagine that there's a 1 here. You can put the 1 if you want to. Actually, I'm just going to put it. So $2 for each yodeler and $1 for each xylophone for a total of $40. So take a look at that, then let's read it again just to make sure we're translating correctly. The conductor charges $2 for each yodeler and $1 for each xylophone. It costs $40 for the entire club with instruments to ride the gondola. Okay, write an equation with two variables that represents the information. We did that. Be sure to define your variables. We did that. Find a combination of xylophones and yodelers that will make your equation from part A true. Is this the only combination? Okay, so what will work here for Y and X? Two times something and plus 1 times something. What could I plug into those to get 40? I'll give you a hint. Okay, so like something like 2 times 15 plus 1 times 10 equals 40. Because 2 times 15 is 30. 30 plus 10 is 40. This is the coordinate 10, 15 because X is here and Y is here. Okay, give me another one that will work. Yes.
Y 20 X 20 wait no, Y 20 X
0. Yeah, right? That'll work. Yeah, yeah. I was hoping somebody would say that one. So 2 times 20 plus 1 times 0. That definitely works. And that's the coordinate 0, 20. It'd be really awkward for them to have 20 yodelers with no xylophones, but whatever. We weren't asked about the reasonableness of the answer. We were just asked for what works. Give me one more. Yeah, Sam. Beautiful. Okay, if I were to graph these three coordinates, what would I get? Look at the original thing. What is this? What shape does this make? Starts with an L. It's a line, right? So if I were to graph these three, I should be able to take a ruler. A line's not a shape? Yeah, okay. What else should I say instead of what type of graph? I don't know. Okay, anyway, these are all coordinates on a line. Okay, that's it for number 68. What do you think we're going to do with that giant resource page? Probably. Okay. 69. Now consider the other piece of information. The number of yodelers is twice the number of xylophones. I'm going to repeat that again. The number of yodelers Okay, what letter is that? Y is equals. What do you do for twice? Yes, excellent. Okay, so the number of yodelers is twice the number of xylophones. Okay, now let's go figure out some coordinates that work for this. What will work here? 0 equals 2 times 0. Will that work? What's another solution? Yes, Brandon.
40 equals 2 times 20.
40 equals 2 times 20. Wonderful. So that would be the coordinate 20, 40. It's another easy one. Beautiful. 2 equals 2 times 1. Okay. So find your big graph. Where's mine? Oh, here it is. Okay. And what I want you to do is take the X down here and label that xylophone. Label the side yodelers. Okay, and we're going to draw 2 lines with our ruler. So if you need a ruler, go grab one. The first line is going to connect these 3 points. The second line is going to connect those 3 points. Okay, so my first coordinate is 10, 15. Zero, 20, and 40, 0 is over here. Okay, if I did this correctly, I should be able to connect those with the ruler. What's wrong? You got to flip it sideways. Make it so the numbers are right side up to you. Yeah, see the X and the Y label on the axes? Uh-oh, I missed the dot completely. And it's pen. Really dark pen. We're just gonna pretend. Throw it. Nice. I think I did it too fast. Okay, so there's my first line. My second line has the points 0, 0, 20, 40. That's not on here. Cripes. Okay. What else can we do? What's the next point? 2040 is not on here. So what's the next point?
10 20.
Yeah. So what we can do is go 1, 2, and then use our slope. 10, 20 works. That should get us to there. Listen, you know exactly where this is going. I know. Okay, so once you get this and you have your point marked, you can be done with the graph. Go back to the notebook. Let me give you another minute in case anybody needs it. Okay, now back to the notebook. I want you to take these two equations from 68, 69, and write them over here next to number 70. So just over here on this side, so write 2y plus 1x equals 40. And then underneath it, write y equals 2x. Okay, now I don't know about you guys, but I sometimes don't feel like graphing. How dare you, Mrs. Talbot? Sometimes you don't feel like graphing? Okay, I know. For shame. Sometimes I prefer to do algebra because it's quicker and easier for me. Now, this is what we're studying in this chapter. We just did solve by graphing, which means that we found the point of intersection with 816. But if I'm feeling lazy, I might want to solve it algebraically. Okay, we are working on distinguishing between the three different methods. The first one, and everyone's favorite, is called equal value, but both have to be equal to the same letter. You see how the bottom one's equal to y, but the top one's not. Okay, so I'm not going to choose equal values method. Okay, if one of them is equal to y and the other is not, I do substitution. You guys see how that is this case here. One of the equations is y equals, the other one's not. Okay, so to remind you, this is what I like to do, and you don't have to do it this way, but this is what I like to do. I like to take, put a box around what y equals, and then make an arrow to y into the other equation. And I'm going to write this equation again, but y is going to be substituted with 2x. So I have 2, the y disappears and substitutes with 2x plus 1x equals 40. I'm going to zoom in. Zoom in. I got you. Just say so. I got this. I have this thing, this little arm deal, and it goes. I just really wanted to make that sound. Okay, anyway, so this is 4x plus 1x equals 40. 5x equals 40. X is 8. Okay, does that make sense from our graph? Yes. Okay, and then for y, I like to plug it into the box. So 2 times 8 is 16. Final answer is a coordinate 8, 16. Oh, it's good. Hold on, hold on. Almost there. Okay, so 71 and 72 are very quick. They are actually a vocab lesson. And I want to talk about the points that we worked with today, 8, 16, 0, 20, and 40, 0. So if you could just write those in. 8, 16, 0, 20, those are just some of the points we worked with today. And this particular problem is not a math problem. I know, this is a vocab problem. And we need to talk about it because when I graded your quizzes, there were a bunch of people using the wrong word. Okay. Okay, we're going to talk about that. This is a point of intersection. Okay, so this word is intersect. This is where they intersect each other. Are you guys okay? Okay, now this point 0, 20 is an intercept. Why intercept? Intersect, intercept. Intersect is where they cross. Intercept is y or x axis. Okay, so big question. C, is it an intersect or an intercept? Intercept. And you can tell because it's got a 0 in it. A few people on your quiz put point of intercept. I did not mark it wrong because we had not done this yet. Okay. Go ahead and set up the last bits. Okay, now for 72, this is what we're going to do. I'm going to put up a problem from the CPM book. You're going to read the problem, we'll read it together, and you're going to decide if the problem has to do with an intercept or an intersect. You do not have to do any math. There's no math to do. You're just going to write the word intercept or intersect, depending on which one you think that problem is. And you're just learning this, so if you get them all wrong, it's totally okay. We're working on it. We're just, okay, so I'm gonna read it, and I'm gonna give you like 20 seconds to discuss it in your group. Here we go. Okay. A 5-gram candle on a birthday cake is lit. 2 minutes after it's lit, the candle weighs 4.2 grams. How long will the candle burn? You're, the only thing you're thinking is it intercept or intersect? Just write down the word that you think it is. Intercept or intersect? Just writing a word, that's it. Okay, B. A local bowling alley charges you $4 to rent shoes and $3.50 for each game you play. Another alley charges you $7 to rent shoes and $2 for each game you play. How many games would you need to play in order for both alleys to charge you the same amount? Intercept or intersect? Intercept or intersect? Last one, B. 2 months after Aaliyah's birthday, she had $450 while her sister Claudia had $630. 5 months after her birthday, Aaliyah had 800. Whoa. That would not be me. I just gotta tell you, I am not good with money, never have been. If I have $1, I will spend it, probably can do something stupid. Anyway, I seriously would not have not spent that $450. Well, just wait. 5 months after her birthday, Aaliyah had $800 while Claudia had Nigel. What's with these amazing girls? I need to learn from Aaliyah. Anyway, how much did each person have on Aaliyah's birthday? Intercept or intersect? Okay, let me give you the very surprising answers. The first one is intercept. Why? Because you want to know when the candle burns to 0. So meaning the height 0. So you got to think about the graph going down. It's burning, and then it's going to go out when it hits height 0. B is intersect. Because the problem said, when do they have the same amount? So that's the clue there, intersect. How are we doing so far? Oh, nice. Okay, now this is the one you might be mad about. This one is intercept. Because it asked you to go backwards and find their start. So how much money did they have back on the start? That's why that one is intercept. Yes, honey.
I got them all.
Excellent. I'm so excited. So it wasn't as hard as I thought it was going to be. I don't know, I thought it was kind of spicy. Okay, last problem of the day. Substitution method notes. Very straightforward. Gonna put a box around the part that's equal to y. And put an arrow to y in the other equation. A box around the stuff that equals y and an arrow to y in the other equation. I'm going to write this equation again, 5x minus 7, but y is going to disappear and be substituted by 6x plus 11 equals -3. Now I have an equation I can solve. 5x minus 42x minus 77. Why such big numbers, Mrs. Talbot? I just wrote it down out of the book. That's okay. I got this. -37x minus 77 equals -3 plus 77 -37x equals 74. Oh, that comes out evenly. Yay. Okay, and then I'm going to put that in the box. Time to wake up. You had to wake up at 10:23 yesterday? Literally 10:23? Specific. Okay, final answer, coordinate. And just to make sure, driving the point home there, that is where they intersect each other. Okay. Let me show you what the homework is and what the joke is. Okay, so we did xylophones and yodelers and substitution method. Homework is 73 to 78. And it says, when a student asks how many points something is worth, it's worth 1 million points. And that's from Austin Powers. If you don't know, it's hilarious. You should watch it. That's Dr. Evil right
I
there.
watched that one.
Everything is worth 1 million points.